Yo, what's up, everybody? Mr. G here. This is the video for 6.2 one-step equations with rational coefficients. So in the previous video, we talked about how to simplify expressions. Today, we're talking about simplifying equations. Now, the big difference between an expression and an equation is the equal sign. Expressions do not have equal signs, and therefore we are not able to find the value of the variable, where equations do have equal signs, and therefore it allows us to find the value of the variable. So we know this variable x represents some number in the world. We just don't know what it is yet. But because there's this equal sign, we get to solve for x, and the goal is to get the variable by itself. If we can do that, if I can get this variable by itself, I can know what it is. So for solving equations, what we do is our ultimate goal is just to use inverse operation. Use the inverse operation. By that we mean opposite. So if you like the word opposite more, we can use the word opposite. So we use the opposite operation. So I have two different problems. One has an addition, one has subtraction. And so what we're going to do is we're going to solve these, and we're going to do them by doing the inverse operation, the opposite. So if I look at here, I have x plus 3.2 equals 7.6. My goal is to get x by itself. So what I need to do is I need to get rid of this 3.6. If I get rid of this 3.2. If I get rid of 3.2, x is going to be all by itself, nothing else. It's going to be x equals something. So I want to figure out how to get 3.2 to 0. So the way I do that is I look here and I say, okay, well, I have x plus 3.2. So how do I get rid of a positive 3.2 or plus 3.2? And we use the opposite, which would be minus. And I'm going to do it right underneath it, minus 3.2. Okay, because 3.2 minus 3.2 is 0. It cancels out. It makes it go away. But the thing with the equations is that whatever we do on one side of the equal sign, we have to do on the other side of the equal sign. So I also need to subtract 3.2 from the right side as well. My x comes down. I haven't done anything with that yet. I can't take away 3.2 from x. But 3.2 minus 3.2, that's 0. It cancels out. Okay, I could write plus 0 here, but there's no reason to write plus 0 because that's just saying, hey, we're adding nothing to this. There's no point in doing that. Okay. I got to bring down my equal sign as well. And I need to actually do 7.6 minus 3.2. Line up my decimals, and I get 4.4. So x equals 4.4 in this specific equation. I'm all done. There's nothing else I can do. What I could do is I could go back and I could plug in 4.4 into my initial equation for x. So I could go, okay, well, I got 4.4 plus 3.2 and see what that equals. Because that was my original equation. Take x 4.4, add it with 3.2. I can add these up and see if I get 7.6. And I do. So that's good because I want both sides to be equal in the equation. 7.6 equals 7.6. I'm good. I did it correct. Now on this side right here, I have x minus 8.1 equals 3.4. So again, I need to think of the same thing. I need to do the opposite in order to get my variable by itself. So to get my variable by itself, I have to get rid of this minus 8.1 here. Because this minus 8.1 is on the same side as the equal sign as my variable. So to get rid of negative 8.1 or minus 8.1, I'm going to do the opposite, which is add 8.1. So I'm adding 8.1 to the left side of the equal sign, which means I'm also going to add 8.1 to the right side. Because whatever I do on one side of the equal sign, I have to do on the other. I can sometimes draw a line down the equal sign because I know that equal sign is going to always keep coming down. Okay, and that shows that if I do something on one side, I have to do something on the other side of that line. So I got to bring down my x. Negative 8.1 plus 8.1, that's 0. Don't need to write that down. That's the whole reason why we did it. Whenever we do something in an equation, something should go away. Something's not going away, we did something wrong. And now I can actually add these to get x equals 11.5. I could plug it back in to make sure 11.5 minus 8.1 is 3.4. Okay, cool. So what we're going to look at next is problems that aren't with addition and subtraction. So we know addition and subtraction are each other's opposite. So subtraction is the opposite of addition. Addition is the opposite of subtraction. So now we need to figure out what operation is happening between 3.2 and x here. So right now I have 3.2 and I have a coefficient as 3.2. I also have an x attached to that coefficient. So whenever we have a variable attached to a number, that is multiplication. Okay, there's no parentheses here, but we don't need them. This is a multiplication problem. So what we know is the opposite of multiplication is division. So we still have to use the opposite operation. So because I want to get my variable by itself, I need to get rid of this 3.2. Because this 3.2 is being multiplied by the variable, I need to do the opposite, which would be divide. 3.2 divided by 3.2, any number divided by itself. If I take 3 divided by 3, I get 1. If I took 4 divided by 4, I get 1. So if I take 3.2 and I divide it by 3.2, I'm going to get 1. If I write 1 times x, so we know this is going to give me 1. So I have 1x left. Okay, but do I need to write the 1 in front of the x? That's just saying, oh, I have 1x. Well, that I don't need to write that 1 in front of an x. Every variable always has a 1 in front of it. We don't need it. Okay, so that's why they cancel out. We get 1 here, which is good. It cancels out, which is what our goal is. Bring down my equal sign. Okay, but whatever I do on the left side of the equal sign, I have to do on the right. Whatever I do on one side, I have to do on the other. So because I divided by 3.2 over here, I need to divide by 3.2 over here. Now, yes, you might actually have to do some work off to the side. That's okay. Definitely show your division if you need to. Okay, but for this one, I know the answer, so I'm just going to do it real quick. And I know the answer is 3. Okay, so I know the answer is 3. So therefore, x equals 3. If I take 3.2 and I multiply it by 3, then I'm going to get 9.6. I take 3.2, I multiply it by 3, I'm going to get 9.6. Okay, which is good because that's what I wanted to get. So I'm done. So because I have a multiplication problem, I divided by whatever is being multiplied, and that was the opposite. Let's look at another. Now, I don't have multiplication anymore. If we look, I have my variable as a, not x this time, which is okay. Variable can be any letter. So I have a variable, and I have a fraction, negative 2.4 equals 5. So fractions represent division. So this is a divided by negative 2.4. So I need to ask myself, what is the opposite of division? Multiplication. So what I need to do here is, because this is being divided by negative 2.4, I need to multiply by the number I'm trying to get rid of. Well, I'm trying to get rid of negative 2.4, because if I do that, that'll give me a by itself. So I am going to multiply by negative 2.4. And I'm writing it in parentheses off to the side because it's going to actually really be on top, because if I extend this out, if we look, I have negative 2.4 over negative 2.4, which is the exact same thing we had. If I go back over here, I had 3.2 over 3.2, and that made 1. Well, now I've got negative 2.4 over negative 2.4, which also makes 1, so it works. So because I multiplied the left side, I also have to do the same thing on the right, which is multiply 5 by negative 2.4. These cancel. I still have my a. I need to bring down my equal sign. And then I need to do 5 times 2.4. Okay. Now let's do that real quick. And it's 5 times negative 2.4. So I should always ask myself, notice how I did multiply by a negative. So I have a positive times a negative. So my answer is definitely negative. Okay. Now I just got to do my multiplication. 5 times 4 is 20. And then 5 times 2 is 10, 12. One number after the decimal, 12. So a equals negative 12. I am all done. I could check my work. Does negative 12 divided by negative 2.4 equal positive 5? It does, but I could check that real quick just to make sure I did my work correctly. Okay. Last problem. Okay, so now we have a fraction. Okay, a lot of us kind of don't like fractions very much, but fractions are actually pretty easy. So I have a fraction that's being multiplied by x. Okay, this is multiplication right here. There's no sign in between the fraction and the variable. So in order to cancel out a fraction that's being multiplied, we could just divide it by that fraction, but there's actually a shortcut. Because what we're going to do is, if we remember, if I were to take 2/3 and divide it by 2/3, let's just show what we would do here real quick. And I'll show you the shortcut as to why. We keep, change, flip. We change it to multiplication, so it's really 2/3 times 3 over 2. If we remember this from a while ago. We flip the second fraction, we multiply them. Well, So what this is called, you guys, this is called the reciprocal. What we're allowed to do whenever we see a fraction in an equation that's being multiplied, if I just flip it and multiply it right away, so if I just flip the fraction and multiply it, it's always going to cancel it out. And this is always what I need to do. So because I have 2/3 being multiplied, I'm going to flip my fraction, just like what we did when we divided. We keep flip, multiply, keep, change, flip, right? So I'm going to flip my fraction and just multiply it. Because if we look, my goal is to cancel this out, right? That's always the goal when we're doing equations. Our goal is to cancel something out. Well, if I were to actually do my multiplication here, if I were to do 3 times 2, that's 6. 2 times 3 is 6. 6 over 6 is just 1. So if I also cross simplify, these all cancel each other out. Okay? So if I flip it and I multiply it, it's going to go away. That's the whole point. So I get 1x, and I get my variable by itself. So I get x equals, it doesn't equal 6. Whatever I do to one side of the equation, I have to do the other. So because I multiplied by 3 over 2 on the left side, I have to multiply by 3 over 2 on the right side. So yes, we can put a 1 in our denominator. 2 goes into 6 3 times, so that becomes a 1, and that becomes a 3. I cross simplified. 3 times 3 is 9. So x equals 9. So if I take 2/3 and I multiply it by 9, I get 6. Everybody try this one real quick. Try doing like 3/4 x equals 20. Just try that one real quick. Should be, actually don't do, don't do 20. Do 21. I'm sorry, 21. Pause it, try it, see how you do. Okay, so I'm going to flip my fraction right here. I want to flip it around. So I'm going to multiply it by the opposite, which is 4/3. That way everything cancels. I'm left with just x. Multiply by the opposite, which is 4/3. And I switched it to 21 just because I wanted the 3 and the 21 to cancel out for you guys, make it nice and friendly. So bring down my equal sign. 3 goes into 21 7 times. So I get 7 times 24 is 28. And I'm done. All right. Cool, guys. Well, hopefully this video helped. The big thing is make sure we're just doing the opposite. We're trying to cancel out things to get our variable by itself. That's the ultimate goal when solving an equation. If you need any help, please let me know. And I almost lost my voice. Thanks for watching. Have a good one, guys.